Welcome to NIWeek. This is my first presentation. It is starting off with a bang. I'm Bob Schor. You may know me as Bob Schor on the forums with that funny thing as my avatar. I'm a professor emeritus at the University of Rochester, and I'm now at the NIH. I went there because my dear wife is now the deputy director of one of the institutes, and I thought I would tag along. I'm going to be talking about something that was introduced in LabVIEW 2016 officially and LabVIEW 2015 as a hidden feature, channel wires. And I think that they are one of the coolest things that has come along in LabVIEW for a long time. And I'm going to tell you why I think so. I'm not going to tell you how to use channel wires, although there'll be a little of that, or what they do for you. But I'm going to tell you why it's such a neat thing. A little bit of background. I'm not an engineer. I'm not a computer scientist. I'm a neurophysiologist. I study the sense of balance, hence my avatar. You may recognize it as the labyrinth of the inner ear. I've been in academia sort of most of my life, except for the last year. I'm now at the National Eye Institute at NIH. I've been doing real time for a long time, starting with the DEC PDT-11 in the 70s. I was the last known chair of the RT11 users group in there. I got introduced to LabVIEW 15 years ago with LabVIEW 7.0. And in my time at the University of Rochester, I became sort of the go-to person for acquisition and control for both animal and human studies. I got introduced to the channel wires hidden inside LabVIEW 2015. I was invited to a little talk that Jeff Kay and Stephen Loftus-Mercer gave, and I said, I want to know more and I want to play. And I became an enthusiastic user and abuser. That means an envelope pusher of channel wires. So I have to, because I'm an academician, I like to talk in terms of metaphors. And so LabVIEW has some really interesting programming metaphors. Loops, that's a graphical encapsulation of a bunch of code that you do multiple times. Sub-VIs, or functions, that's a tiny little thing you put on your block diagram that also is a graphic representation for something happens here. If you're good, you put an icon on it so you know what's happening there. The principle of data flow. Wires carry data to be acted upon, and there's some rules. Loops don't start until incoming wires have data. You've got to have data in order to do something with it. When the loop exits, the data just sort of magically appears on the outside wires. And I don't know how this works in Arabic or in Israel where they run backwards, but loops input come from the left and they go out on the right. Interesting. Same thing applies to sub-VIs and LabVIEW. Okay, the principle of data flow, this is something I learned really early on, means that LabVIEW is essentially a parallel language, because if you've got two loops or two structures that don't have the output of this going into the input of that, there's no way to tell which executes first. And so NI has done a really good job of trying to make sure they operate as close to the same time as it can make your computer do it. And if you've got a multi-core computer, sometimes they can actually do it at the same time. So when you've got parallel loops with great power comes great responsibility, or something like that, their parallel loops are very common. Produce a consumer design pattern, a queued message handler, but how do you communicate between them? Sometimes data has to pass from one to the other, or they have to operate on the same kind of data. Well, globals, I pushed the wrong button. Globals and local variables, that leads to race conditions. Queues, I'm going to talk about queues in a bit, but there the data flows backwards. That always bothers me. There's some additional synchronization functions which I rarely use, and then there's asynchronous channel wires, and we're going to be talking more about that. So when I got started, I was handed a big project. How do human beings locate sound in the dark? So we had some sounds that moved around, and we pointed lasers at them. And it was lots of stuff, and written in LabVIEW 7, very badly documented, and somebody said, here, fix this. And I said, well, I got to learn a little bit about how to design things in LabVIEW other than one huge block diagram with gazillions of wires running through it. So I looked at this thing called the Q message handler, and I'm looking at this, which is the diagram that you get when you bring up the example, and I said, what's going on here? And I was bothered by the Q wires and the fact that the data which is being, which is being generated here, and is being DQ'd here, and here it's being NQ'd, and here it's being NQ'd, but when it's being NQ'd, it has to go all the way back here and come back into this function. I didn't get it. So when I started writing my own code, I tried to abstract this in some ways that made more sense to me. I tried to make my code a little cleaner. This is actually from my own code, and here is a little routine that creates the Q and puts the first init in it, initialize, and there's the DQ, and here we're going to do something. We're going to put this message in here, the message handler after all. And how does the message get back here? Well, it travels backwards through here and then comes back in. And here's an error handler. It also puts an error message, maybe if there's an error. And again, it flows backwards. I didn't like that, so I wanted, and all those wires, Q wires floating around the diagram, confused me, and I didn't like it, so I said, Action Engine. I'm going to put everything inside an Action Engine, and I called this the InvisiQ, because the Q is invisible, it lives inside here, and the only reason you have it is you have to get the Q out so you can DQ it. And all the Q features are in here except DQ. First time I made this, DQ was in here too, and it didn't work. Left the exercise to the reader why that was, but never mind. But there's the Q's. This Q it's the same thing. This is calling the Action Engine, and this is the Action Engine. This is the Q is in here. So this gets rid of most of the Q wires. That's the only one you see here. But now you can't see the data flow anyway. It's sort of hidden inside here, and it's, again, a problem. So I had the metaphorical issues with Qs and QMH. First of all, it's a minor one. The Q, you need to do at least 4 things. You need to obtain the Q, you need to NQ, you need to DQ, you need to release. You can encapsulate this to a certain extent, but the DQ, as I said, must be standalone. That's not a big deal. I was bothered by the fact that the data appeared to flow backwards through the Q wires when you NQ it. And the Q data flow rule is not intuitive. I realize it's a structure and it's a reference, and so it doesn't matter, but it's still, I'm thinking data. I'm a scientist. I like to follow the data, and the data were going in the wrong direction. So is there another way? So the use of the invisible Q engine hides the wire, but also hides the data flow. Is there another way? You want something that's Q-like, but with forward data flow, to produce the flow metaphor, and something that can encapsulate the asynchronous metaphor. Enter our friend, the asynchronous channel wire. The asynchrony is because it looks different. It looks like a big pipe, and it sits on top of structures. You don't tunnel through a structure, you jump over the top of it. So it goes over the edge of structures. And I'm not going to go over this. There are several different channel types, some of which sound familiar. There's a stream channel type. It's a lossless, one-to-one, mostly between producer and consumer, just like the producer's consumer queue. There's the tag. It's a lossy many-to-many, like a notifier. There's a messenger, which is what I'm going to spend a lot of time talking about. It's lossless, but many-to-many, like the queued message handler queue. And there's also, if you like using, I keep pushing the wrong button. If you like user events, there's an event messenger, but that wasn't in 2016 when I was developing my code. This is in 2017. So, in a channel, there are only two functions: a reader, which puts data onto a channel, a writer, which puts data onto a channel, and a reader, which takes data off the channel. And what's nice is they can sometimes do housekeeping chores, like saying, is the channel really done? A stream, for example, has a last element that shuts down the channel, safely terminating loops. You don't have to put a release on the producer, which causes an error on the consumer. So you know if you get an error, maybe you're done, but maybe you're not. Maybe it's a real error. This is much cleaner. So this is the same thing we've been seeing, but now I've replaced the queues with channel wires. So this thing, the other thing I tend to do, because channel wires are so different, I bring them out the top and bottom connectors. See the pipe? It's really different. It looks different. It looks like a pipe. It's got flanges. It goes over the top. So here we're generating our initialize. We're bringing over here to our receiver. Over here, we're going to send another message. It comes out. It goes over the top, out the edge, around the back, coming out. Nice feedback loop where it gets received. And this is instantaneous. Put it on here. Whoosh, it's ready to go the next time. And nothing stops it. I mean, once this function finishes, you're done with the loop. You can come back here and start the next loop. So it is asynchronous, it is instantaneous, it goes, it preserves the metaphor. It comes out, goes around, and comes back in. So you can see data flow. Data flow is maintained. Okay. This is the same queued message handler example I showed before, but now I'm going to replace it with channels. Here is the initialized. This is their what do I want to say? This is enqueue, or create a message. It comes in here. This is read the message. Create the next message. It's going to come around, read the next message. The event loop, create a message. Comes around, read the message. It's just so simple. These are also generates a message. Okay, it's the same message. Put it on the message. Comes around. So I mean, it just, you can see what's happening. It's simple. So, I'm going to use this in a large project called Project Mirroring. Mirroring is Latin for mouse. We're monitoring mouse behavior. What the behavior we're monitoring is called micturition. I'm not going to tell you what that means, but I'll tell you a colleague in the Department of Urology came to me and said, I want to do this thing. I want to study micturition behavior in mice. He had a cage that would hold a mouse. And we called this thing a station. Underneath the cage was a balance, a Mettler balance that put out weights at 10 hertz. Every 10 hertz you got a Visa message. It told you what the mouse was, shall we say, excreting. There was a camera associated with the station that you could watch the mouse and see what he was doing or she was doing. And you could make videos if you wanted to. Now, so we didn't want to do this on one mouse. One mouse, one experimenter, that's a lot of time to wait for the experimenter. We had it so you could have, we had 24 of these stations. We could run 24 of them and 24 mice simultaneously. Data collection, typically, we ran for, say, 2 to 3 hours. And during that time, the mouse would give us maybe 15 or 30 ADI videos of interesting behavior that we were interested in, or they were interested in. Okay. This is merely in action. This is its front panel. It's pretty simple. There are a couple of controls up here that, that let you choose what the name of the experiment is, start and stop it. This is a status and selector. I remember I said there were 24 stations. In this particular example, we're running 5 of them. And they're called 17, 20, 23. Don't ask me the numbering system. I just followed what my colleagues set it up. They numbered them further. But this is how they're. So you can see we are looking at station 20. There's the camera. There's the tail of the mouse. You see the mouse's tail. There's the balance. It's weighing things for us. And this is its view from the camera. So we can see the mouse behaving. And there's a graph of what we're measuring with the balance. So we have a couple of indicators, the video, the graph of the output of the balance, and this status thing also is an indicator of what's happening. The black symbol there, somewhere a channel, a station failed, probably Visa goes haywire, coming over TCP, and okay, something got stuck. And so it went black. So we know we can't push that button anymore. Can't look at it. There's Yuri. That's not quite, but that's the program. That's the top level VI. And it is a channel message handler. Okay? It has its message, and it's starting off with a net neurine. There's an event loop. If we push one of those status buttons, it means we want to change the station. And so we come here and we say select station. Oh, I think I maybe went too fast. Yes, I skipped this slide. Here we're looking at station 15, station 15, station camera 15. And if I push button 20, it just instantaneously switches, and you're now seeing the simultaneously recorded data from a different channel. So that's switching back and forth. So if we push one of those buttons, we'll select the station, we'll come around, we'll show you, it'll come here, and that's the select station case. It says, what station did we turn on and off? Send a message. We have references to the thing that's running the camera, show that in the camera view. We have the chart from the balance, put that in the balance, so we see the sub panels. We're just populating the sub panels. All this is happening all the time. There's another messenger channel coming down here. We record every time there's a state change or anything significant happens. We want to know station 3 went into this state. So that gets all piped in here, and we record it in an XML file here in the spooler, and that we send a message that says save something on the station key. station on the event file. Sorry. It's another channel message handler. I won't show you that one. There is a tag channel that's up going from mirroring up to the event loop. It's only there to stop the event. And like I say, I would have done it with a user event, but that wasn't present in 2016. Okay, here's all that mirroring does. Mirroring is built as a master-slave. The slave is the station. Mirroring is the master. It launches the stations as asynchronous clones. So we can take one copy of a BI and clone it 24 times. Saves wear and tear. It sends messages to a station telling it that we want to see your front panels. We want to change the graph of the time scale of the graph. Those are the only messages it sends to stations. It gets data from the stations and spools it down in its event file. The stations are slaves of mirroring, but it also is a master to 3 other channel message handlers. One called camera, which runs the camera. One called balance, which runs the balance, and one called video that just makes a video, an AVI file whenever somebody tells it to. So these are the messages mirroring have. They're very simple. Most of it has to do with configuration. It starts the station, it selects the station, changes the scale, and it says quit. This is the station channel message handler. It's showing the init station state. It has inside it a channel message handler to run its balance, a channel message handler to run its camera, and a channel message handler to handle making the video that you might want to make at a certain point in time. We'll get into that in just a second. It has a number of states. When it starts off, remember it's the master for the camera, balance, and video. It starts the camera by sending it start. So when the camera does that, it's going to come back and give it to here. It's sending a message out, which is coming back in, which is saying, this is my front panel reference that you can send back to your master, mirroring, because it'll need to know that. Okay, it has a bunch of messages. I'm not going to go through all of them, but basically it's just handling, running its own slaves. Masters run slaves. And so that's what it does. Here's the balance channel message. This is responsible for reading what's happening on the balance, and what we're looking for is a change in weight. The mouse puts something on the balance. And when that happens, we want to take a video of it. And so once this gets running, it has 3 possible states depending on what's happening. It can be idle, nothing is happening, the mouse is just happy. It can be, oh, an event has started. I am recording an event. And it trigger for going from an idle to an event happening is the balance, the weight on the balance change. And so finally, and then there's the state where the weight on the balance stops changing. That says, okay, my event's over. So idle, pre-event, post-event. What happens in all 3 of these states is we read the weight on the balance, and we update our graph that we're always making of what's happening. We save the data to a file so we know at all times what's coming out of this. And then depending on what state we're in, we make a decision on whether we want to stay in the state or transition to another state. And that tells us what the next state is, based on what's happening in the current state. So, again, these are its messages. It starts, have we selected the station as one we want to see? We want to see its graph. Have we changed the scale on the graph? And then it's doing most of its thing by reading the balance, deciding if it's in its idle, per-event, or post-event state. And there's one other thing in the middle of the state that alternates with it, update graph. I should have shown you that. Update graph. There's update graph. So it sends itself a message, update graph. So it's in idle, it sends itself update graph. And here it sends itself maybe another idle. So what happens? We've got two things on this, on the our list of things to do. One is update graph. It'll update graph, and then we'll go back and do idle, or update graph, per, update graph, post. This is just a trick to interact, to interpose one update graph between any two states of, is the balance stable, is it changing, whatever, because we always want to save and update our graph. Okay. The camera, this is a very simple thing. It just mainly, once it gets started, it just sits there and takes frames. 30 frames per second, saves it in a buffer. The one interesting thing is we don't want to be displaying things. We don't want to waste our time making images on a front panel. We only want to do that if that's the front panel, if that's the station we're looking at. How do we know? The station says, I want to look at, Noreen said, I want to look at station 20. If this happens to be the message handler for station 20, when we say select, it'll come in here and it will turn on view. View will be on. And it will take the image that it's saving in its buffer and put it on its front panel. All the others are off. So we're only at any one time looking at one image. And if we don't want to look at any images, we can turn them all off. And then this thing will run a little bit faster because it doesn't have to spend time making images. Okay, and as you can see, it has almost no messages. You start it, you select the station, decides whether it's on or off, you take a frame. The video gets started, the balance says, aha, something changed. Time to start making a video, but you don't want to start making the video when the balance changed. You want to go maybe a second earlier. So you use images saved in iMac DXs in the camera buffer. So this has the responsibility of keeping itself in sync with the camera. Fortunately, iMac DX, all the data you need is saved in the camera. So if you've got a reference to the camera, you can tell what the current buffer is. You know where you are, because when we start this, when we open the AVI, we get the last buffer, that the current, where we are in the camera, at this right, yes, where we are, and we save it so we know. We basically keep track of where we are, where we have to start, and we're going to be saving, we're here now, we want to save from earlier, so we start saving, and we'll eventually catch up to where the camera where the camera really is, and then we just keep going in sync with the camera until balance says we're done. And then we say, oh, maybe we're going to save 5 more images. We save 5 more images and we close the AVI. Sounds like magic. It is magic, but it works. And again, very simple messages. Now, there's a problem with all of this. And the problem is that, remember I started off by saying stations are clones. And they're launched by start asynchronous call. But you can't wire a channel to an asynchronous clone. That was awful. And how do we get messages back from stations to Murine? Again, we cheat. We use a pair of queues. When we generate the station, we generate a station-specific queue that's passed as an input to the start asynchronous call. So now, if Murine knows what that queue is, it can pass it into a queue that the station sees. We use that to send the messages to the station, like select station. The stations only need to send 2 things back to the camera. Back to the Murine, namely the balance and the camera references. Well, I use the InvisiQ business. I put it in an action engine and I ship it off. Now, why didn't you see that? Because I cheated. I didn't show it to you. So this is really Murine's block diagram. There's one extra piece here. This is the InvisiQ. There it is. It's being dequeued. I'm sorry. This is the Murine message queue that the station, that the camera and the balance and the camera references are being put on by the station. Here it's getting taken off, and it's comes in here, and it's being saved as where is it being saved? I'm not showing you where it's being saved. I'll show that to you in just a second. But when we need to generate the station, when we create the station clones, hold on. Well, I'll show this to you. I'm getting myself confused. But this is giving us the information. I am getting confused. What this is telling us is where to find the references for the front panels of the balance and the balance and which has got the graph, and the camera which has got the image, so that we can put them in the front panel and see them. Yes. Where's the image? That's the image. Hold on. Oh, so here when we create the station clone, we create it with a queue, and here are all the queues for the station. So when we want to send a message to a station, the way we do it is if we find the station we want to send a message to, we put it in its clone, and in the station block diagram, there's the queue that it was wired in when it was called. We take any message that comes off, and we send it here. So, for example, we might have sent the message. We want to know the balance clone's address. So we come in here. It sees we want that. We want balance clone. Okay, send it. There's the InvisiQ. We're putting front panel references to Murine, and so in the Murine case, it'll come up here. We take it off, and we put it in. I'm a little nervous because my computer died, so forgive me for being a little bit explore Milenko. Now, hopefully I'll be able to do this with this borrowed computer, which is running not LabVIEW 2016. Oh no, I can't do this because I'm missing things. Dadgummit. I'm gonna, maybe, and time is charm. Let's just see if I can get this thing to turn on. I can't show you the code. I'm sorry. So there are some implementations and caveats with channel wires. Yeah, I can't show that. Well, I'll try. So one of them is how are channels represented? They're actually represented when you create a channel. You create, through scripting in the background, a type-specific LV-lib. By type-specific, it'll say, and it'll have a name like messenger, and the name of the message, of the type depth that you're using.
Your laptop came up.
Sorry?
Your laptop came up.
Ha! Thank you. Thank you. Forgive me, I'm going to try to, because this is, I really want to show you this. Let me just, where it is. Let me see if I can get this to come.
Probably Windows Update.
Thank you. That's, you know, that's not so dumb. And I don't mean that to be as nasty as that sounded. I don't want that.
It always happens at the worst possible moment.
Yeah. It only happens when you need it. Okay. Now, where is the, let's see if I can get this to work. That's the right way, that's the right way. Let me just, did it do it already? Wow. Why couldn't you have done this much earlier? Then I wouldn't be so nervous. That'd be 2016. I'm using the reason it wouldn't work for 2019 is I'm using the XML library in the LabVIEW Tools Network, GXML. I like it a lot. Okay. Oh, Control E. All right, I wanted to come over, I would have had all this ready, of course. Create station clone. Here's create station clone. Go away. So I want to create a clone for station 1. So there's a little bit of mapping because I showed you that the stations aren't numbered 0, 1, 2, 3. They're numbered 1, 2, 3, 4, 5. So there's a mapping between where the stations actually live and sort of where they live on the diagram. So there's a little bit of mapping that we do between the squad, which is the mouse number, and the between what the number of the station is and what the position in the array is. So we have to do that sort of mapping. And then I'm actually naming the queues, although I don't need to because they're actually never referred to by name, only by wire. But I'll name it Q03DS. I don't know what the DS stands for. I make the queue, and it's the only thing that's passed into the start asynchronous call, and this is just the standard way of doing it. The other thing I wanted to show you was wait, hold on. Well, I can, I wanted to show you. In LabVIEW data, there's a folder called LabVIEW 2016 32-bit, extra VI Live, and here are all the channel instances. And you can see there's a bunch of messenger channels, and it's a messenger, and this is the type of the message, so that's the data type that's being carried in it. Now I have to go back to my talk because I wanted to, and I don't have the talk up. Sorry, I'm really embarrassed about this, but never mind. NIWeek. Really. There it is. I'm going to have to zip forward here. Sorry.
I have a question. Is there a way to bundle or put channel wires into an array?
No.
Pass between?
Not at present.
Do you know if there's any plans for that?
I think the man that might know.
I don't think so.
Here somewhere, there he is in the back.
I mean, it seems like you're creating a workaround. Like if you would take it the next step forward graphically, you would want your top level VI in the middle of your diagram and channel wires kind of exploding out to all your stations if there was a static input.
Except I don't want to have to write. Oh, I see what you're saying. Instead of doing start asynchronous call, just put 20 of them out there.
I realize that's a limitation to having the flexibility of
Yes.
dynamically launching it.
Yes.
To me, it seems like one of the benefits of the channel wires that you kind of are able to create a better graphical visualization of what's happening. Like that station block diagram is a good visual representation of the lower level stuff.
Yes.
And if it could be expanded towards the top level, and you had a static implementation, like you didn't need to create one test station with 10 and one with 20. It would be, to put 20 on the block diagram would be a good.
Well, and in fact, one of the reasons we did it that way is what determines how many stations we create. It's how many mice are we running.
Okay.
And that can vary from day to day. It is true that because of the way mice are, if we were running 2 experiments at the same time, experiment 1 would use one set of cages and experiment 2 would use another set of cages. And so you might have 6 and 12 and they'd be different. And you'd know at runtime because the first thing we do is load the mice in with another program that creates a data structure that says exactly what mouse is in what station. And so at runtime, it has to be flexible. So anyway, I was telling you another thing about the implementation is that because this is in a folder in my LabVIEW data folder, channels are saved on a per user, not a per project basis. And part of the reason I had a long discussion with some of the developers of this, part of that is that they didn't want to overload the project with all the code that gets created, to handle the scripting. They wanted to do once and be gone and not have to load it each time. You just have to be a little bit careful. You can have name clashes with other projects. And somebody said to me, aren't they in LV-libs? And I said, yes, but I have had problems. And maybe it's, I don't remember where it came from, but it's just something to be careful about. try to keep, if you've got different projects, try to keep the names a little bit special. Sometimes if you're loading many channel wires at once, the system can hang. And I don't quite know what the reason for this is. This one mine just loaded without any problems now. I think that's probably because I am using I'm using SP1 of 2016 when I first started. If I had tried to load everything at once, it would not necessarily load. You can get around that usually by, instead of loading the whole project all at once, you go, load part of it, half the VIs at a time. If it still is hanging, you can fix it, usually. And the way you fix it, this is my machine, right? You're looking at my machine, good. The way you fix it, how do I get my thing back? Come on. Oh, there we go. The way you fix it is you go and oh, come on. You go into where the channel wires are. There they are.
We're not seeing your screen.
Sorry?
We're not seeing.
You're not seeing the screen. Why aren't you seeing the screen?
You might want to.
Oh, I have to do something to, how do I pause? Oh, I have to minimize it. Sorry. Minimize. Now are you seeing the screen?
No, so the escape.
You're still seeing the
We're saying the escape key.
escape key.
May have to put the mouse on
Did that do it? No, came right back.
Right, Alt Tab.
What am I doing wrong?
Good.
There it is. Thank you. Okay. What I was going to do is come over here and go in here, extra VI Live, and I am going to just delete all the channels. Delete. They're gone. Now, I am going to close. I'm just going to try to open my VI again, and it should say regenerating channels, and it's going to try and regenerate all my channels for me. And so if you do get hung up, or you do have a clash between you writing a new project and things don't quite work because you've got the old channels from another project sitting in there, you can just get okay, it wants me to reload everything. I'm just going to reload the project. What was I saying? So you can okay, try once more to load name. Now generate. Yeah. If you've got a name clash specifically with a different project, you can just get rid of all the channels definitions and just load the project you want again. It'll regenerate everything if you're lucky, and if you're not, you load it in pieces. Oh, look, it's going to work. Passwords. Okay, so I want to go back to my slides because I have a final message or so. Oh yes, there's my slides. Yes. Oops. I have to go to. Wonderful. I need to learn this trick. Okay. I just showed you generating channel levels. So I want to summarize my 3.5 years of channel wire use and abuse by the following little things. I think channel wires are a very powerful visual metaphor for asynchronous data flow. It always flows left to right. It's visually distinctive. It runs in a pipe, not a wire, suggesting that it just, well, I say it's able to leap tall structures with a single bound. I hope that resonates with some of you. It's very simple. There's a writer, and a reader, and point-to-point wiring. I think it's conceptually simpler than queues, notifiers, and message queues. It's just from here to there. Many of the channels, particularly the stream channel, has built-in terminals. The people that designed these things said, you know, one of the problems with queues is how do you know when the queue is done and who tells you? And I happen to be, I never took computer science, but I did read books. And I learned a long time ago about queues and about something called a sentinel, which is a message that you send in the queue that says, that's it, I'm done. So the proper way to shut down a producer-consumer queue is not to have the producer release the queue. It's to have the producer knows when things are done because it's generating the data. And you say, okay, I'm done generating the data. You end the producer loop. You don't release the queue, you put a unique thing on the queue. If you're sending DAC-MX, you're normally sending an array of data. You send an empty array. That's unique. The consumer looks at the data that's coming in. Have I got the sentinel? Have I gotten the unique signal? If I have, I know the producer is done, so I can exit. And once I exit, I can release the queue because I know the queue is done. This producer has finished. He's told me he's finished. He said, I'm done, so I can, that's safe. Here we've got the same thing. The streaming channel has a thing that says last element. When that puts it on the channel gets destroyed after the reader reads it, of course. Okay, so I think that the resulting LabVIEW code is cleaner and more intuitive and easier to explain to people, and they have fewer wires, and they all run in the right direction, left to right, unless they're coming feedback. Okay, questions? And I apologize for the technical difficulties, but thankfully it cured itself. And thank you for your help.
You pulled.
Are there any
You
questions?
handled it with grace, Bob.
Thank you. No question. I'm here all week. I will be shutting my equipment down. Anybody wants to come and talk, that's great. What? Yes?
So just on the last slide, you talked about kind of the benefits of channel wires with these incidental signals.
Yes.
Would you say that those outweigh the difficulties that you've had using channel wires?
I haven't had any difficulty using channel wires.
Oh, so then yes.
I'm sorry, would they outweigh?
I mean...
most of the time, I'll be honest, most of the time, most of my channels have been messenger channels because I've been using the channel message handler. and it doesn't have Sentinel-like things. But when I do streams, I always use last, when my producer says, I'm done, I always have it send last element. And on the receiver, I always check that and use it to exit the receiver. So, and again, it's a proper flow of data. The producer knows it's done, it sends a message to the receiver or the consumer, and so the consumer says, okay, we're all done, and it exits too. So it's just, it continues the metaphor of data flowing from the guy that knows to the guy that's gotta know. From producer to consumer. And not, and in a natural way. I mean, in the queue, in early queue message handlers, where they showed you just early producer consumer pictures. I don't remember where it was. Where they showed you release the queue at the producer side, and that causes an error down here, and that's how you know the producer has released the how you know it's done. Well, you might not have processed the last element yet. It's dangerous. So, yes.
Hey Bob, anything you would add, you would want NI to add to channels that they don't have now? Any features you feel are still missing? Or?
They keep adding new channels. I haven't had a chance to interact with all of them. There are more channels than I have used. I've used messengers, I've used tags, I've used streams. There are variants on all of these. You can have it with or without an abort. I haven't used those. I have used the channel version of user events, and those are quite nice. The way for the same reason that user events are good for event loops, a channel user event is good for event loops too. It's basically get messages up there when you need it without having to use a timeout. Okay, thank you very much.